Yo, sixth grade students, this is Mr. Bornheimer. Today we are going to look at a brand new equation for a different type of energy. So let's do a quick recap. Yesterday we looked at this idea of kinetic energy. And one of the things that we focused on was this equation of mass times speed times speed and we put this entire equation over 2. And one of the things that I really emphasized, I'm pretty sure in the first class, and maybe didn't emphasize as much in the second class, but it is really important, is that all the units that we use are metric units. Okay, so mass has to be in kilograms. Speed has to be in meters per second. And these metric units are really important. We cannot have speed in miles per hour and we cannot have mass in kilograms because when it's all said and done, kinetic energy will have units of joules. Which is the universal unit for energy. Okay, so that's kind of a recap of yesterday's equation. Today we're going to look at a brand new equation for gravitational potential energy, GPE. Okay, gravitational potential energy is not the same as kinetic energy. Kinetic energy is all about movement. Gravitational potential energy is different. Gravitational potential energy is all about height. Okay, so let's go ahead and get started. Gravitational potential energy equals the mass of an object times g, which I'll get to in just a minute, times h for height. I'm going to have to go ahead and erase this big word over here. Okay, now you might be wondering, well, what's g? Well, g is gravity. And believe it or not, gravity has a value. For our purposes, gravity is going to equal 10. Okay? So let's say for a second that we know that an object has a mass of 7 kilograms and it has a height off the ground of 6 meters. Now again, remember, in these problems, we have to use metric units. So we can't say feet, we can't say inches, we can't say pounds. We use kilograms for mass, and we use meters for distance or height or anything that we're measuring length. Okay, up, down, left, right, forward, backward, whatever. So in this particular problem, it'd work out something like this, where we'd say this equals mass, which is 7 kilograms, times gravity, which is 10, times the height, which is 6 meters. And if you do all of that math, you end up with 420 joules of energy. So this is how you find gravitational potential energy. So the primary difference between kinetic energy and gravitational potential energy, again, is one's looking at movement and one's looking at height. And we see this in the math. If we look at these two equations, I'm going to highlight them. They both have mass. So check, they both have mass, but one has speed and one has height. One deals with movement, okay, and one deals with the height off the ground. All right, so this is what we're looking at and what we're working with as we get into this idea of calculating energy. So let's look at a scenario, another scenario. Let's say that I have a shelf like so, and I have a box sitting on that shelf. This box doesn't weigh a whole lot. By weight, I mean it doesn't have a great amount of mass. The mass is equal to 4.5 kilograms. But the height off the ground is at least 3.2 meters. Okay, so the first thing we're going to do is we're going to create a toolbox for this problem. A toolbox, okay, for gravitational potential energy looks something like this, where we have mass, we have lowercase g, we have h, we have GPE. So in this case, the mass, not terribly difficult, is going to be 4.5 kilograms. G, little g is always 10. You can just leave it at that for now. Okay. The height is 3.2 meters. And we don't know GPE, and that's where this whole idea of the question mark comes into play. Okay, so we have more than enough information. So I write my equation, gravitational potential energy equals mass times gravity times height. Mass, gravity, height. So all I do at this point is I plug in my numbers. So I have 4.5 times 10 times 3.2. Okay, so if I were to do this math, pull up a calculator here. We will see 4.5 times 10, which will be 45, times 3.2 gives us 144. Now, if I were to stop there, this would not be okay. Okay? It's really important that at this point we take it to the next level. And the next level looks something like, what are the units? I don't know what this number means. You have to have the units. So I'm going to go ahead and I'm going to add a joule, and boom, we're good to go. Okay? So if you're reading through a problem and you're trying to decide, do I use kinetic energy? Do I use gravitational potential? If it's dealing with speed, kinetic. If it's dealing with height, gravitational potential energy. All right. Use these ideas, use these notes, use these equations to fill out or answer the questions that I have posted to Google Classroom. You can do the work on a separate sheet of paper, and we'll go over these problems when I return on Monday. Thanks for watching. Have a good day.